In this tutorial we're going to use Kruskel's algorithm to find the minimum spanning tree. I'm assuming at the moment you've already looked at the previous tutorial on Prim's algorithm, and Kruskel's algorithm does the same thing but in a different way. So again we're finding the minimum spanning tree, which is the shortest network to join all the nodes. And again, the definition is the same. A node is a point on the network, and a network is a set of paths joining the points. So what's the process that we go through to find the minimum spanning tree with Kruskel's algorithm? Well, this time, rather than having a particular starting point, we just pick the shortest path that's on the network anywhere, and we continue doing that provided we don't create a cycle. When we can't pick any more points, we've finished. If we have two paths at the same length, we can pick either of those paths. It doesn't matter. We might end up with a different minimum spanning tree to somebody else, but we will get the same weight for the solution. And remember, the weight of the solution, the weight of the tree, is the length of all the paths added together. Okay, so let's have a recording. So here is our network, and we want the minimum spanning tree. So with Kruskel's algorithm, we just look for the shortest path, and we can see that that's CF with a length of 1.9. So we select CF, and we write down what we're doing so that it can be followed later on how we selected our paths. We now look at the diagram again, and we just look for the shortest path. Now it does not have to be connected to C or F. In this case though, that does happen to be the case because the line EF with 2.2 is the shortest path. So we select that path and we write down that that's the one we've picked. We then pick the shortest path. Again, it does not have to be connected to C, E or F. It would appear to be the line CE with a length of 2.5. But if we pick that one, we create a cycle. So we go to the next length up, which is 2.6. We write down that that's what we did, and we now look for the shortest path. And this time it's clearly 3.4, again connected to what we've got already, but it didn't need to be the case. And we write down what we've done. We've now got a choice. There are two paths that are 3.5. It doesn't matter which one we pick, and I'm just going to pick AB. I'm going to write down what I've done, and now any other paths that I pick will create a cycle, so I must have finished. So to work out the weight of my problem, I add the 1.9 to the 2.2 to the 2.6 to the 3.4 to the 3.5, and the weight is 13.6. Here's one for you to try, to do on your own and to share your results with your friends. I've also included in the description below a link to a worksheet with 6 other questions that you can try as well. I hope you found this tutorial helpful. Staying in field with Winfield.